Good day, grade 12 learners. I hope you are all well. Okay, so welcome back to our lesson. Today we're mainly focusing on the mid-latitude cyclones, right? A mid-latitude cyclone is a low pressure system that occur over the tropics, right? And it has few characteristics that you guys should be able to identify as well as know. Okay, now let's just look at what a mid-latitude cyclone looks like first before we go into the characteristics, right? As we look at the picture, I want us to look at few characteristics. Most importantly, its movement, right? We can all see that it moves from west to east, right? And then there is also an anti-clockwise movement of air, right? And another thing you guys should know, you should always remember that it is driven by westerly winds. The wind in which it comes from drives it, right? Okay. It is also formed between 40 and 60 degrees Celsius, both in north and south, but forms between 30 and 60 degrees, both in south. Great. Now I want us to have a picture, to look at a picture that has another characteristics of this mid-latitude cyclone, right? Okay guys, now we're looking at a picture of a mid-latitude cyclone but in another form where all the fronts are now visible and identifiable, right? Okay, now we can see that there are 4 features of fronts, but we're only going to focus on the warm front and the cold front. And when we further going to look at the cross section of a mid-latitude cyclone, we're also going to look into more detail of warm front as well as the cold front. Okay, now this is a mid-latitude cyclone, right? But we can also see that there are 2 high pressure cells underneath the mid-latitude cyclone, right? And guys, don't forget that this is a low pressure system. Okay, now the high pressure on the left, it's called the South Atlantic high pressure, which causes cool, dry winds unto southwestern Cape. Hence, a mid-latitude cyclone occurs in Cape Town during summer. Right. The one on the right is called the South Indian high pressure, which causes warm, moist winds to blow onto east coast. Guys, I now hope that you guys are writing notes, right? Because this is the most important things that you guys should know. When you get into your exams, you should be able to identify these. Okay, now when you see another high pressure that is on land, right? Now that is called a Kalahari high pressure, right? But we're going to look at it into more detail when we look at the cyclotic map. Okay, great. Now back to the cold front. We can define a cold front as a transition zone where cooler air is replacing warmer air mass, and it forms behind the mid-latitude cyclones, right? As you guys can see that it is always behind, right? Okay, guys, I think all of you here, all of you watching this video, have experienced a very cold, unstable weathers. Maybe not once, maybe not twice, but many times, right? Where there is extreme coldness, right? There is snow falling, there is rain with very cold winds, right? Now that is what we call a cold front, right? A cold front has occurred, right? Now back to the warm front, right? The warm front is when mass of warm air meets an area of cold air. Now this should be easy for you guys to identify as well as define, right? Great. Now, the warm front is always in front of the mid-latitude cyclone. Just like how the cold front is behind, the warm front is now in front, right? Great. Now, I want you guys to be able to understand how warm fronts works, right? Now, I'm going to play you guys a mini video of an explanation of warm front so that you guys don't forget what a warm front is, how to identify it, right? Please see the following video, and then we'll have a mini activity to do after. Right.
Imagine this as you and your friend. You as the mass of warm air and your friend as an area of cold air. You are behind your friend, running to her. And then you overempower your friend, who is the cold air, and you rise, leaving the cold air to sink.
Okay, learners, now it's time for you guys to test your knowledge to see if whether you've been listening to me or not, right? Now, I want you to distinguish between a cold front and a warm front. It can be any difference you see or that I have mentioned earlier, right? And you have only 2 minutes to do so. Okay, learners, now your time is up. Okay, I hope this activity will help you understand the cold fronts as well as the warm fronts, right? Okay, so let's look at the possible answers to the question that I gave you guys. Great. Great, learners. Now let's look at some of the answers that you guys should have written in the activity. Right. The first one would be cold front is behind the mid-latitude, whereas the warm front is in front of the mid-latitude. Right. I expect that you guys, all of you, should have got this right because I've mentioned this earlier in the lesson. Okay, let's move. A cold front is associated with low pressure system, which brings cold and wet weathers, whereas a warm front is associated with high pressure system, which bring warm and dry weathers. Okay, and also a cold front is a mass of cold air which moves into an area of warmer air, whereas a warm front is a mass of warm air which moves into an area of cooler air. So with this difference, right, with regards to the warm front, you can start with a mass of warm air and then finish with cooler air, so that you guys don't forget, right? And with cold front, you can start with a mass of cold air and finish with warmer air. This is just a strategy for you guys to not forget. And remember, one thing that you guys should know, these two, there are definitions of warm front and cold front in its simplest form. So if you guys don't get this right, then I don't know. Okay, now I want us to look at the final difference between these two, which would be visible now in the screen, right? You guys are seeing it in the screen, right? Now, the warm front is symbolized by a curved red line with semicircles, whereas a cold front is symbolized by a curved blue line with triangles, as you guys can see on the screen. Okay guys, I hope you guys got most of it correct. Great, even if not now, but soon you will. As you keep practicing and reading, you will. Right. Okay, so in the comment section, I'll leave a link for you guys for the warm fronts and the cold fronts. If you want to look up more about them, then as the perfect link, it will be the first link in the comment section. Right, make sure that you make use of it. Now let's look at the stages of a mid-latitude cyclone. Right, as we all know, a situation doesn't only happen like just happening, right? There are few stages that needs to occur in order for that to happen, right? Now let's look at these 5 stages. But remember, we're looking at the 5 stages now, but later we'll be focusing on only 3, because you guys are going to write about only 3, right? Great. Now these 5, we'll look at them more into detail after naming them, right? The first one will be the initial stage, right? The second one would be the open stage. The third one would be the mature stage, and the fourth one would be the occluded stage, and the fifth one will be the dissipating stage. Right, now let's look at these into more detail. Okay, learners, these are the 5 stages that we are going to focus about. Right, the first one being the initial stage. That's where a wave forms in the polar front caused by jet streams, empty range, or coastline. Okay, and also a low pressure cell develops where winds deflect as air blows onto low pressure cell along pressure gradient. Okay, you guys can see it's still stationary, and as it is stationary, it forms a front called stationary front because they are not moving yet, they are one, right? The second stage being the wave stage. Okay, cold air mass moves southward onto the west side of the cyclone, and warm air mass moves northward on the east side of the cyclone. Okay, as you guys can see that a wave is also forming, right, in the second stage, right? Then we go to the third stage. Guys, remember, I'm not dwelling much on the second stage because it is not mostly important for you guys to know, right? But you should know it. Okay, now I want you to dwell much on the third stage, which is the mature stage, right? As you see these red arrows, that's where the warm sector is situated because of the cold air and the cool air of the warm front. Okay, now the warm sector is situated between cold front and a warm front, right? And behind the cold front, that's where we find the cold sector because air there is cold. Okay, now let's move. Wave deepens and a stronger pressure gradient develops. Remember, on the initial stage, we said that air blows into low pressure cell along pressure gradient. Now that pressure gradient is getting stronger on the third stage. Okay, then polar front forms cold front and a warm front. Okay, you guys should be able to know this. Air blows in an anti-clockwise direction into the low pressure. As you guys can see, the arrows around the low pressure, they are going anti-clockwise. Okay, we move to the fourth stage, which is the occluded stage. Right, there is cold dense air that sinks and wedges underneath the less dense warmer air. As you guys know that warm air is the one that rises. Cold dense air is the one that sinks and stays at its lowest, right? And lets the warmer air to be lifted off the ground up until to the clouds. Okay, the warm sector appears to be narrow, as you guys can see that on the low pressure it's starting to be narrower. Okay, as cold front overtakes warm front. So the reason why it's getting narrower, the warm sector is getting narrower, it's because cold front is overtaking the warm front, right? And then this forms nimbostratus clouds that brings light rainfall. Okay, we move to the fifth stage, which is the dissipating stage or the degeneration stage. Okay, now here there's only cold air at ground level. Rain and clouds clear up because there is no longer a stronger pressure gradient. The mid-latitude cyclone is no longer stronger at this point, right? It has to clear up. Okay, learners, now let's tackle this question together. It's about a stage of development of a mid-latitude cyclone. Okay, remember when I told you that you guys should master the mature stage? All right, let's look at the first question. We're naming a front labeled A. Okay, now you see a curved line with triangles on top of it. Now you know that as a cold front. All right, the next question is that we're stating the type of cloud that is associated with the approach of a mid-latitude cyclone, and such type of cloud will be a cumulonimbus cloud because it is the one that brings heavy rainfall with thunderstorms as well as unstable weather conditions. Okay, we'll see that more in the cross section. Okay, so the cloud is cumulonimbus clouds because it brings heavy rainfall behind the mid-latitude cyclone. Right, the third question, we're naming thunderstorm cloud associated with front A. Okay, we already know that front A is a cold front, so we're basically naming thunderstorm cloud that is associated with cold front. Right, okay. Cumulus clouds are mostly common clouds produced by the cold fronts, right? But they often grow into cumulonimbus clouds, which then produce thunderstorms. So there is cumulus clouds before the cumulonimbus clouds, right? Which means the cloud is cumulus clouds. Okay. The next question is that we're naming the term to describe the process when a cloud front catches up with the warm front at the apex, C. Okay, now this stage is known as the occluded stage, right? When a cold front catches up with the warm front, that stage is called the occluded stage. So the term here is called occluded. Okay, because the cold front catches up with the warm front and it overtakes it, then that's when the warm sector becomes narrower. Okay, right. The last question says we must identify front D, which really affects the weather of South Africa. You come across with a curved line with semicircles, then you know that it is a warm front. Okay, now I hope you guys understood that. Let's move together. So, what I want you guys to know is that we mainly focus on those three that I mentioned earlier, right? That will be the stationary or the initial. Then we'll also look at the mature stage as well as the occluded stage, right? I want you guys to know that you should be able to identify these three. In a mature stage, you should be able to identify what features are identifiable, right? What features are visible in that mature stage, right? As we looked at them earlier, right? You guys should be able to know them. Great. And you should also know which is which and how to draw them, right? Great. Now, we'll be looking at the cross section where we look into more detail of the cold fronts and the warm fronts, right? Okay, guys, and don't forget, if you come across mid-latitude cyclones that go together in groups, right, those are called family of depression because they are in groups, right? Okay, and also don't forget the movement of the mid-latitude cyclone. Let me give you a strategy, right? And whenever you come across a mid-latitude cyclone, just simply take a ruler and a pencil, put them on your paper or on your map, right? Draw a line across that mid-latitude cyclone. At the end of that line, you can put an arrow, right? Then you know that's your movement of a mid-latitude cyclone from west to east, right? Don't forget. Okay, now we're looking at the cross section of a mid-latitude cyclone. Now we can see the cold front and the warm front in a more clear vision. Okay, right. I want you guys to redraw this diagram in your books. As I am saying few points, I want you guys to note it down on the diagram. Okay, right. Now, the cold front is steep. Okay, it has a steep gradient, whereas the warm front has a gentle gradient. Okay, right, because it is laying low. Okay, now we also see that there is a warm sector. In the warm sector, we find warm A, as I've mentioned earlier in the mature stage, right? We find warm A. Okay, right. Now, behind the cold front, there is cold air, which moves to the east of the system, right? As it moves towards the warm sector, it combines with the warm air, which will result in cool air. Because when you mix something that is cold with something that is warm, it results in being cool, right? So in this case, we'll now have cool air. That will be the air in front of the warm front, right? As we already have air that is behind the cold front and air that is in front of the cold front, that will be in the warm sector. Now the only air that is to be said, or that has to be there, is the air in front of the warm front, right? And this air is called cool air. Okay, now when the cold air reaches in the warm sector, right, it goes underneath the warm air, right? The warm air will now rise. Okay, as it rises, remember, cold dense air do not rise. Cold air don't rise. The only air that rises is the warm air, right? As it rises, right, it forms clouds, and those clouds are called cumulonimbus clouds. Okay, these clouds forms heavy rain as well as thunderstorms. Okay, right. Now in the warm front, the clouds that form on the warm front because of the cool air, right, it is called the nimbostratus clouds, which brings light widespread rain. Okay, this rain doesn't have much effect of the mid-latitude cyclone. The only clouds that have much effect and have many weather changes, right, that brings about many weather changes, as the cumulonimbus clouds, because it brings heavy rainfall with thunderstorms. Okay, now the general movement of the system still moves from west to east. Okay, right. So guys, we have spoken about the warm front as well as the cold front, right? I hope we are clear on those. Okay, now cold dense air moves under warm air rising above cold air, and the cold air moves away. That's how the system should be. Okay, now guys, this is the most important section that you guys should know, the most important diagram that you as grade 12 should know. Okay, should be able to identify which feature. Okay, now let's move to the end. Now we've come to an end of our lesson. Like we literally looked at most of the main ideas that I wanted us to focus on today, right? We looked at what a mid-latitude cyclone is. We looked at the cold fronts and the warm fronts. We looked at the stages of development of a mid-latitude cyclone. We also looked at the cross section, right? And I hope that you guys will use this video effectively, study, as well as use it for your exams, right? Okay, now I have a quick task for you guys to tackle if you have been listening to me all the time, right? Great. Now look at the activity, and guys, remember, this is for your own good, right? To tackle your knowledge, take the activity, do the activity. You may not do it today or now, but take your time to do the activity, right? Because you might come across some of the questions here in the exam, right? Then you'll be able to know, okay, this question I should answer it this way, right? Okay, Thank you guys for being great listeners. And if you have made it this far, I thank you, which means that you guys have been listening to me, right? I thank you. See you in the next lesson. In the next lesson, we're going to focus about the weather changes and as well as the effects of the mid-latitude cyclone. Right. Thank you guys.